In question, functions f and g are defined like this. Let's take the range of f. Okay, so this is my fx. X minus 2 whole square minus 4, right? But we know that x minus 2 whole square is always greater than equal to 0, right? Because it's a perfect square, or a whole square of anything is always greater than equals 0. Now we have to subtract 4 both sides. So x minus 2 whole square minus 4, 0 minus 4. Now it became fx. So fx is greater than equal to minus 4. So this is our range. Now let's move to the second question, f inverse. So we can assume this as y. So y equals x minus 2 whole square minus 4. By the way, what's the domain? Domain is this, x greater than equals to, and the range is, we already found, minus 4. Okay, so y plus 4, add plus 4 both sides. Y plus 4 equals x minus 2 whole square. Now we can write x minus 2 whole square equals y plus 4, and we can write x minus 2 equals plus minus root y plus 4. And x equals, we can write 2 plus minus root y plus 4. Now we know that for finding inverse, we have to change x as f inverse x and y as x. So we are gonna get f inverse x now. So that is 2 plus root x plus 4, or f inverse x equals 2 minus root x plus 4. But the interesting part is we have to select one of them. Now which one we have to select? Let's check over here. We know that for the function's domain will be the range of inverse, and the range of domain will be the range of the function will be the domain of f inverse, right? So what's the domain, guys, for function this? Greater than equals to. So range of f inverse, here we can find f inverse x should be greater than equals to. It means positive and greater than 2. Now you can check. This is 2 plus, right? This is 2 plus, but this is 2 minus. So it is subtracting. It is decreasing from 2 and it is increasing from 2. And what's the range, guys? F inverse x will be greater than equals to. So 2 plus something. So this is valid, right? This is valid. And this one we have to reject. So this is my f inverse. 2 plus root x plus 4. This is my f inverse. It's a good question. Now given that a equals minus 5 over 3, solve the equation fx equals gx. So which is fx? This one, x minus 2 whole square minus 4. So x minus 2, yeah, yes, x minus 2 whole square minus 4. So guys, this is x minus 2 whole square minus 4 equals gx. What's gx? Ax plus 2. Ax plus 2. Now we can expand that. The x square minus 4x plus 4 minus 4, and a is minus 5 by 3x, and this is plus 2. 4 got cancelled. We can multiply by 3 both sides. So this is 3x square minus 12x, and the 3 and 3 cancel. So this is minus 5x, and 3 times 2, that's 6. Okay, 3x square, and this is actually minus, and we multiplied by 3. So this is 12 minus 12. 3x square minus 12 minus 5 and 6, yeah. So 3x square minus 12x, and the 5 will come to left side, and that will be 5x, and 6 you have to take to the left side. So 3x square minus 7x minus 6 equals 0, right? Now guys, we need to solve. So we need to solve this. What we can use here? Can we use a calculator for that? So this one, yeah, x squared coefficient is 3, then minus 7, then minus 6. How much I got x equals 3 and I got x equals minus 2 over 3. Okay, so we got two possible values of x, right? Now we have to check whether can we select these two values or not. So this is fx and gx, so we have to go back to our question. No, we have to think, see, for fx, x is greater than equals 2. So let us understand. For fx, this is 2 for example. For fx, it is greater than equals 2, this side. Okay, that's the domain. But for gx, all real number, right? All real number. But what's the common domain for these two? If we are discussing these two combined, then we have to think about the common domain. So common domain means, or the common values of x, which will satisfy these two together. That's x is greater than equals 2. So guys, when we are gonna discuss these two together, then we have to think about the common domain, right? So common domain, which is x greater than equals 2. Now we have to think about x should be greater than equals 2. So this 3 is valid, but minus 2 over 3 is invalid. So this x equals 3 is the right answer only. Now D part, what's that? Given instead g of f inverse 12 is 62, find the possible values of a. So first of all, we have to think about f inverse 12. So we already found f inverse here. F inverse 12 equals 2 plus root of 12 plus 4, because 2 plus root x plus 4, right? So x will be 12. So this is 2 plus, and 12 plus 4 is a 16, then that's 4, that is 6. Okay, that's great. Now we have to find g of f inverse 12. That's equals g of, but f inverse 12 we have 6. Okay, it means we need to find first g of 6. Okay, so g of 6 we need to get from here, which is ax plus 2. So gx is ax plus 2. That's great. Now we need to find g6, but a is given. Oh, a we need to find. So g6, so that is a times 6, so this is 6a plus 2. Okay, so g of 6 I got. Now guys, g of inverse f, oh, this one we have to remove, and yeah, g of f inverse 12 will be g of, and g of f inverse 12 is 6, so g of 6. Now g of 6 also we got, that is 6a plus 2. So now we need to find g of 6a plus 2. Okay, so again, change x as 6a plus 2 in this, right? So what will you get? A times x has changed to 6a plus 2, and we have plus 2, right? Now this is 6a square, and that's 2a, and that's 2. So this is g of f inverse 12. That's great. And this value we have over here, that's 62. So actually 62 equals 6a square plus 2a plus 2. Okay, now shift 62 to right side. So you will get 6a square plus 2a plus 2, and 62 we have to take to right side, that's equals 0. So 6a square plus 2a minus 60 equals 0. Now we can use again calculator for that. So yeah, so that is 6, then 2, then minus 60. How much we got? We got 3. Okay, 3, and minus 10 over 3. By the way guys, this is a, right? And do we have any condition on a? No, a is constant. So a is constant, so a can be any a. So a will be 3, this is also valid, and a equals minus 10 over 3, this is also valid. So these two will be your answer.